Okay, so we'll run through our last presentation for the day. So thank you for coming to hear a little bit about civil engineering at Dalhousie. My name is Rebecca Clahane, and I am a fourth year civil engineering student at Dalhousie.
And my name is Duna, and I'm a third year civil engineering student at Dalhousie.
Civil engineering can be split up into a bunch of different categories. The first category is structures. At large scale, this can be the Burj Khalifa, which is the tallest man-made structure in the world. Or at small scale, it can be the medical examiner's building in Dartmouth. Small scale could even be your school or apartment buildings.
So something that civil engineers are known for are building bridges, whether it be a large-scale bridge like the Confederation Bridge in PEI or a small-scale bridge like the Miners Marsh Trail Bridge in Kentville. Civil engineers are the ones in charge of designing and building these bridges. And a fun fact is both our bridges, the McDonald and McKay Bridge, were designed and built by civil engineers.
Marine is another category of civil engineering. At large scale, this can be the Halifax Container Terminal, or at small scale, it's the Government Wharf Road. Both of these need to be strong enough so that when a ship ties up to it, it doesn't collapse.
So there are two main types of offshore structures, and one would be the oil platforms and the other would be the wind turbines. And of course, like the things that we've mentioned earlier, you need a civil engineer to design and build these structures. And the cool thing about offshore structures is that obviously they're not built on land, they're actually built in water.
Hydrotechnical is the next category of civil engineering. So this is where we get our hydropower from. The example in the picture is the tidal power project in Annapolis Royal. So although civil engineers don't design the actual turbines which create the hydropower, the earth contours, the building, the housing, and the roads all are designed by civil engineers so that our power station works properly and efficiently.
So transportation and traffic control systems is pretty much the designing and building of roads and highways and knowing where to put the traffic lights based on the traffic in the neighborhood and such things like that. So to put it in a day-to-day example, say you're going from your house to the mall, all the roads that you'll be driving on and all the street lights that you'll stop at, they were all designed and built by civil engineers.
Water and wastewater treatment is another type of civil engineering. Although civil engineers don't design how the water actually gets cleaned, we do design the tanks, the pipes, and the buildings, which help us run efficiently so that we get clean water to our homes.
So you might be wondering why and how a civil engineer will be working in a garbage dump. And it's because it requires a big hole to be made. So a civil engineer would be in charge of excavating and constructing this hole, along with making sure that there's no leakage that goes into the soil to harm the environment or the people. And another role that civil engineers would play in this is that they need to monitor and maintain them and make sure that everything goes well, and they have to check it quite often.
Remediation infrastructure is another type of civil engineering. So this is when we take a damaged environment or infrastructure and make it better for a future generation. The example on the slide is the Sydney tar ponds in Nova Scotia.
Municipal infrastructures is pretty much just the basic physical systems such as roads, curbs, streets, and sidewalks. And some of the underground infrastructures involve water and wastewater pipe systems.
Really cool category of civil engineering is heavy structures testing. So this is when we take the concrete, steel, and timber that we would build buildings out of and see at which loads we can apply and that they break. So this tells us how to design them so that they don't break this way in buildings.
As a civil engineer, computer-aided design is a very important and useful skill to have. And computer-aided design, which is also known as CAD, is a software on your computer that helps design and analyze a structure to create a database for manufacturing. And within the courses that you'll be taking for engineering, you'll be taught how to use CAD.
Civil engineering students can really work all across Canada in multiple different types of jobs. If there's a place that you want to work or a job that you want to do, you can most likely find it anywhere in Canada.
So each year of engineering consists of 2 semesters, and each semester you'll need to take about 6 courses. And the courses that you're seeing on screen right now are the main ones that you'll be taking starting 3rd year and up, because that's when it gets discipline oriented rather than the first 2 years, which is more basic broad information. And the main branches of the courses are the ones that are stated on screen.
Projects and lab experiments are a big part of civil engineering at Dalhousie, whether it's a cart that goes a certain distance to complete an objective, a concrete cylinder which you test and see at what force it breaks to see how strong it is, or an earthquake building which tests how you think about the entire project as a whole. You can design the building super strong, but if your foundation is your kind of last thought, your building will fail because of its foundation. Dalhousie has 2 different societies that really help extend that hands-on learning about civil engineering. The first one is the concrete canoe competition. They create a concrete canoe every year and compete either nationally or internationally with it. And there's the ACI Society in competition. The society competes in 2 competitions per year. The first competition that we did last year was a reinforced T-beam that we got to design, build, and test. And the center picture is actually bowling balls that were infused with foam beads so that they were light but still strong. Any questions about civil engineering or engineering as a whole?